So this is our current implementation of weighted graph, but I'm not quite happy with this implementation. Why? Well, the concept of a node and an edge are tightly related. So it would be better if our node class had a list of edges, just like the node class that we implemented earlier for a binary tree. Each node of a binary tree has a reference to its left and right children. So once we have a reference to a node, we can navigate the tree. This is a more object-oriented approach. But here, first we have to look up a node using a string in our first hash table. Then we have to go to our second hash table to find the edges of that node. There is a disconnect here. So I'm going to get rid of this adjacency list and have each node store its edges. Conceptually, we're still having an adjacency list because we're storing only the edges that exist, not the combination of all edges. So we don't have an adjacency matrix. But this is going to be an object-oriented implementation, which is different from what data structure textbooks teach you. So let's get rid of this hash table over here. We immediately have a few breaking changes. Don't worry about them. We're going to fix them real quick. So in the node class, we're going to introduce a new field, private list of edge. We call it edges. And here we set this to a new instance of array list. Now we could also optimize this. So instead of having a list of edges, we could have a map of edges. This way we can quickly check to see if a node is connected to another node. We don't have to iterate this entire list, but let's leave it for the future. So each node has a list of edges. Now, I would like to add a public method here, public void add edge. So we want to connect this node with another node. What parameters do we need here? The target node and the weight. Okay. Now in this method, we're going to create a new edge object and add it to this list. So we call edges.add, and here we pass a new edge object. Here we need to pass 3 arguments. The first one is the from node. That is the current object over here. So we pass this, which is a reference to the current object. The second argument is going to be the target node. And finally, the weight. So we use this public method to add an edge to a node. We don't care how a node maintains its edges. Currently, it's using a list. In the future, we might replace the list with a hash table. As long as we rely on this public method and don't go in the implementation, we're going to be fine. So we're not going to have breaking changes, okay? Now, let's fix the breaking changes. In the add node method, because we don't have the adjacency list anymore, we have a compilation error. But we can safely delete this line because now when we create a new node object, that node automatically initializes its edges to a new array list. Let me show you. So when we create a new node object, the edges field automatically gets initialized to a new instance of the array list. So we don't have to do this manually. So this is going to make our implementation shorter and cleaner. We could also get rid of this local variable because it's only used in a single place. So we can pass a new node object with this label over here. That is better. Now let's look at the add edge method. Here we have a compilation error when adding an edge, but that is super easy to fix. All we have to do is to call the add edge method. So we call from node that add edge. We pass the target node and the weight. Similarly, we call toNode that add edge. We give it the from node and the weight. Look, our new implementation is shorter, cleaner, and more expressive. It's easier to understand than this previous implementation, right? So delete and delete. Now finally, we need to fix the print method. So here we need to get the list of nodes. Currently, we're getting them from our adjacency list, but we can easily get them from our nodes hash table. So nodes.values. This method will return all the values in our hash table. These values are node objects. So let's also rename this to node. That is better. So for each node in this graph, we want to get the neighbors of that node. We can go directly to node.edges, but this is not something that I recommend because this edges field is implementation detail. Tomorrow, we might replace this with a hash table. If we do that, this code is going to get broken. So to prevent that, we're going to go back to our node class and introduce a new public method. So public, we return a list of edges, call it get edges, and currently we return just the value of the edges field. Now in the future, if we change the type of this field to a hash table, then we can convert that hash table to a list by calling the values method. So the client server class are not going to get affected. This is the only place that we'll have to modify, okay? So let's return the edges field. Now back to the print method. Here we call node.getEdges. So let's rename this variable to edges. That is better. I believe we are done, but let's test our program. So let's quickly run it. There you go. We get the same result as before, but now we have a cleaner and more object-oriented solution.